And before I do this, I want to emphasize this. Okay, I have so few students here, but I still want to emphasize this. Share with your partner, your classmates, okay? Don't copy the code from others. Okay? Just show whatever you have. In the demo, make sure your code has no syntax error, can run, okay? And then we just grade based on whatever features you have. Okay? Make sure your program can run. If your program cannot run, you get nothing. Okay? But if you didn't do too much, it's still better than copying from others. Okay? And if we see this problem, okay, so we will basically neglect, we don't care who is copied from whom, okay? So both on the side, you will get penalized equally, okay? We don't care who is copying with whom. So it's also dangerous if you give the code to someone for free, okay? So I want to emphasize this is because actually I found plagiarism. Okay. So again, you are encouraged to discuss with others, but this is not a valid reason that your code are more than 50% same. Okay? So every time this is realized, we will report to the NUS. So please treat this seriously. Okay? If you share codes with others, you're also in danger, basically. Okay? So just some quick revision about what we have learned last week. Okay? Last week we see systics. Okay, we see systics. It is a interrupt. Okay, and I think yesterday I sent some slides to further explain this. I sent 3 slides to further explain this. Okay, so basically this is a line you add into your code to enable your systic interrupt. And the value you put here determines how fast the interrupt you generated. Okay? How fast you generate your interrupt. Basically, you need to make the decision how fast you want your systic interrupt happens. Then, based on this frequency, you give the value of m. So let's say if I want my interrupt to happen in 1 kilohertz, which means every 1 second I want 1,000 of interrupts, which also means between 2 interrupts you have 1 milliseconds time. Okay, so the frequency of the interrupt will be 1 kilohertz. So the 1 kilohertz, 1,000, this value should be put here. Okay, so here you write 1000 so that you are generating a 1 kilohertz systic interrupt. Okay, and the time between them is 1 milliseconds. Okay, then what will happen is every time there's an interrupt, your main program get paused and you jump into the systic handler. Okay, that's why if we declare a variable here called msticks, we do msticks plus plus, the variable is increasing every 1 millisecond. Okay, so msticks increase every 1 millisecond doesn't because of its name. Okay, you can give any name to the variable. Okay, how fast it get increased is due to the frequency of your interrupt. Because you set the interrupt 1,000 Hertz, what happens here is carried out in that frequency, basically. Okay? So, systic handler is actually something extra you want to run, okay, out of your main program. Okay? So, basically, you don't want to write a too long program here. Means you don't actually want to pause your main program for too long. Okay? So it's not suggested to do that. And once you know this, you will use systic to handle all the timing issues, okay? So no purposely delay. No delay functions. You shouldn't have delay functions in your final code, okay? And the application of SysTick, you see the temperature sensor, okay? Because temperature sensor is giving you temperature information by its period, which is in unit of time. That's why the temperature sensor actually requires your time scale, okay? Like how long is 1 millisecond. It needs that information. That's why when you initialize your temperature sensor, you need to have your MSTICs passed into it, okay? And another example is the counting of 7 segment. Okay, let's say 7 segment, you count every 1 second, okay? So to handle the time, you need SysTick. And others like RGB blink with a certain frequency, okay? As your assignment 2, RGBs are required by blinking in 2 Hz, I think, right? So those kind of features you need to handle by SysTick, okay? And you have seen how to program a SPI device, okay? You have seen this. Your 7 segment is using the SPI interface, okay? The way you program this one is, okay, this is the way how SPI devices talking to your master, SPI master, okay? So to use the device, you need to have a init SSP function to initialize, to configure these pins. Okay, this function is given, so you need to copy over. Okay, and then you can do the application program, like you write your main program how to use the device. And for I2C, okay, so who have tried my exercise, the composite light, who have tried this one, knows how to use I2C. So similarly, okay, I2C devices are talking to master in this way. So again, some common channels. So you need to configure the channels of your I2C by calling this function. So if you are using I2C devices, you better have this function inside your main code. Okay, so these are mainly for the step 2, the software configuration. So the software, okay, step 2, software configuration. Okay. Then this is the exercise I left to you last week, right? So I want you to provide composite light to ambient using LED array. Means in this exercise you have 2 devices. You need the light sensor to tell you what's the light intensity of the ambient environment. So that's the input you need to know first. Okay, and then you have the LED array. So based on the ambient light, you want to light up more LEDs if your environment is dark. You want to light on less LEDs if your environment is bright. Okay, so to do this, you have 2 devices. So if you are using these 2 devices, okay, so you need, okay, this one is running I2C, so you must have that init I2C inside. Okay, and step 1, you set the jumper. Step 2, do the software configuration. Okay, so you need to have I2C initialization. And then step 3 is program your device, how to use them. Okay, so for light sensor, if you look at the library for your light sensor, okay, you have many functions. But to achieve this exercise, you just need these 3 functions. Okay, so light init is the initialization of the light sensor, but actually this function is empty. So if you don't call it, it's still okay. So basically, light enable is the one does the actual initialization. Okay, so This is the actual initialization function. And this is the application function you can use to get the value of your light sensor. Okay? So this two should be outside the while one. This one should be inside your while one. Okay? And you have the PCA9532.H. This is basically for your LED array. Okay? So this one, you have the initialization function, you have the set LEDs function. This allows you to turn on different numbers of LED. So how to use this function? I ask you to try this to understand what's the meaning of the first parameter, what's the meaning of the second one. What's the meaning of the first one? What's the meaning of the first one? What's this? Anyone?
On the LED, which is
It's the LEDs that you want to on, right? So it's called on mask. Okay? This one is off mask. Okay? So can you see this is a hexadecimal number? How many bits do we have here? 16 bit. Okay, so this one you have 16 bit. This one you also have 16 bit. How many LEDs do we have in the LED array? LED array, how many LEDs do we have? You have 16 LEDs. Okay, 16 LEDs. So basically, each bit here is indicating, if you write any one, you write 1 here, means you want to light up certain LED. Okay, that's why it's called on mask. Wherever you write 1, you want that particular LED to be on. This is off mask, means wherever you write 1, you want the corresponding LED to be off. Okay, so that's the idea. So you have on mask, you have off mask. So let's say if this is 16-bit, let's say I write 1 here, the rest of the place, they are all 0. What does it mean? You want to on the, let's say, LED 0. And here, if I write 0, 1 here, what does this mean?
off. This
You
one.
want to off LED 0. Now my question is, if I do that function and inside this I have 0x01, 0x01. I say I want to turn on LED 0. I also say I want to turn off LED 0. So what will happen for my LED 0?
Conflict.
Sorry? Blink.
I don't think so. It's conflict, then nothing happens.
I mean, if once I explain this one, explain this, you will come up with this kind of question, right? Common sense, right? People will ask this kind of question. If I say I want it on, I also want it off, what will actually happen? Okay? So, this is something, I mean, you should ask yourself if you have done this one. So, if you look at the code, PCA95, yeah. So this is a function, right? PCA95632 set LEDs, LED on mask, LED off mask. Can you see that? Okay, so just now who cannot answer what's the meaning of these 2 parameters, you haven't even opened your library to see. Okay, and read here. I say there are descriptions here, at least you should read this one. Okay? So LED on mask. This one, what does it mean? The LEDs that should be turned on. The mask has the priority over LED off mask. This is LED off mask. The LEDs that should be turned off. So look at after you read this, what will happen if I put this? It's on. Can you see that? Because the on mask has higher priority than your off mask. Okay? So see, if you have looked at your library, you should know. Okay? So, or if you try, you can try it on your board, right? So this is something you need to know. So this one, higher priority. Okay, so this is this one. If you haven't done this, okay, so basically it looks like this. So basically you need to call the init I square C, this one must be there. And you should have light init and light enable, these two for the light enableization. Then you have PCA init function as well. Then in the while one, you are going to use your light read. Light read will give you the lux return. So I define another variable to get the value. And make sure the type here is the same as the type that your function returns. Okay, and here I didn't do too much. I just set two levels. Basically, if the light is lower than 400, I will light up some of them. If the light is greater than that, I will light up the others. Okay, so that's all. But for your case, you can do more steps so that the behavior of your board looks more linear. Okay, more gradually increase or gradually decrease. Okay, and this is another example. I ask you to display your accelerometer's reading on the OLED screen. Have you done that? Not yet? Okay. Then this is something you need to know, because in your assignment 2, you need to display the accelerometer's reading on the OLED. Okay, this is same like part of your assignment 2. So again, here you have two devices. You have accelerometer, you have OLED. Okay, and this is a schematic for accelerometer, this is a schematic for OLED. So if you look at your accelerometer, is actually running in I2C, running using I2C interface. And if you look at your OLED, it's actually running in SPI interface. So to do this exercise, you need both init I2C and init SSP. Okay? And then you also need to look at your libraries. See what functions are available for this and for that. Okay? You haven't tried, so it's no point to talk about this. Okay, quickly. You need to have these two initialization functions. You need to check the header files, see what functions are available. You have more than that available. But to achieve this exercise, you just need this. So OLED init is the initialization. Accelerometer init is the initialization. Accelerate allows you to read the x, y, and z values. What's the pointer? What's the star mean? You should pass the address of your variable. Okay? How to pass address? Think about it. OLED clear screen. This is to clear your screen. So basically, you have the OLED. You have your OLED very small screen, and it's actually only can display two colors. This is your OLED screen. Okay? So if you look at it very, very carefully, you will see these are the dots. So these are the pixels. Okay? So this is nothing much but same as all the other display. Okay, even your television. your phone display, okay, your iPad screen, your computer's monitor, okay, they are working in the same way. So you see a number here is because these pixels are light up. That's why you see 2 over there. Okay? And for your OLED, okay, for your screen, let's say your computer, every pixel can display different color. That's why you see your screen is a color screen. But for OLED here, every pixel can only be either on or off. You don't have other colors. Okay? There's one pixel here, just like your LED. Only 2 states, either on or off. Okay? So if it's on, you see it in white. Okay? So if all the pixels are on, you see your whole screen is white. Okay? And if all the pixels are off, you see your whole screen is black. That's all. Okay? So basically, later on, you want to display some message here. Okay? So if it is a good practice, like before you display, you turn off everything purposely. Okay? That is called clear screen. Okay? Either you turn off all the pixels, or you turn on all the pixels. You are basically clearing your screen in white or black. And similarly, OLED ToString allows you to display a string on your OLED. Okay? So if you look into this function, inside it, you are actually still turned on pixels. Okay? But someone has already created this function for you. So what you need to do is just give the correct value to your string. You are able to display your string. Okay? But there are other parameters. What does x, y mean? What's the meaning of x and y?
The reading from.
Okay, so this is a moment you need to read your library. Okay, don't guess. I mean, you can guess once you read it. Then you verify your guess by implement something and check your board. Okay, but you are not guess from nowhere. Okay, so look at the OLED.c. So you have the function. Okay, let's say let me see, OLED display string, circle, rectangular, clear. You see OLED clear screen, OLED put character, OLED put string. Is it put string? Yeah. Okay, so this one. Okay, you have many parameters required by this function. You have x, you have y, you have p star p string, you have fb, you have bg. Okay, so star p string is easy to guess, right? The pointer pointing to the string that you want to display. What's the meaning of x, y? Let's say I give you a string. I ask you to display hello on the screen. Are you going to ask me some additional information? Ask for additional information? You want to know where you want to display. My screen is this big.
Yes,
okay? So XY is actually the location of your string. Where do you want to put your string? Okay? So they are referring to the positions. And you have other two parameters, FB and BG. So if you look at the data type of the FB and BG, the data type is called OLED color T. Okay? This seems not a common type, right? So actually this is a type defined in the library. So if you look at the header file, OLED.h. Okay, can you see here? I define a data type called OLED color T. And inside here, you have two options. Okay, so you have OLED color black, OLED color white. Okay, so if you look at the function OLED toString here, okay? So this one you have parameter FB, you have parameter BG. Can you guess what's the meaning of these two? So the FB and the BG, either of these have two options, black or white. So what are we doing here? What is BG? Background. Okay, so this one is actually your sentence, your text. Okay, so basically when you want to display a string, you can decide, because remember I said this one only have two colors. You can either display the text in black or in white, and your background is the opposite color basically. Okay, so you have this flexibility to do that. Okay, so I mean all what I'm saying here is if you or me, this are just your guess. Okay, then how to verify it? Put some value over there and observe from your board.
How do we put the coordinator from X and Y? How do we know that?
Yeah, so at the beginning you actually don't know the range, right?
Yeah.
Whether my X should be 1, 2, 3, 4, this kind of thing, or I should put like 10,000, 2,000, or 1,000, right? That's the moment you try, okay? So try some value, okay, random value. Let's say you just put 1,000, 2,000 and see, okay? See what will happen here. And you put 1 and 2 and see, right? Try and run. Then you verify, okay, basically which direction is X, which direction is Y. You don't know until you try it. And where is 0? Let's say X, Y, it must be a origin 0, right? Is there here the 0, or here the 0, or here 0, here 0, or the middle the 0, or anywhere is 0? You all don't know, right? You need to try. That's why I give you the exercise. Okay? So these are the functions you can use. Okay? But how to do that? Okay? Because you see, to achieve this exercise, your string is not a constant. You are not displaying hello world and no change. You are displaying some changing thing, your X, Y, and Z value. Okay? You are displaying some changing values. Okay? So, which means your string is actually a variable. It's keep changing. Okay? So how to change a variable? So basically the idea is here, okay? So the idea is basically you know if you have a string, you can display on OLED. Okay? But to do this, to confirm this string, you need to read your X, Y, and Z values, and you need to put this value to the string and then display the string on the OLED. That's the sequence. Okay? So to get this value, you know that you need ACC. ACC read allows you to get the value. But how to do this? Okay? So this one you also know. This one you do OLED put string. Right? If you have string, you know how to display. This function is given. And how to get the number, you all know. So the thing is here, how to put this value into your string. Okay? So here I give you a hint already. Okay? So what you need to do is at the beginning you define an empty character array. So basically at the beginning you define your string as empty, so nothing inside it. Okay? And then later on you need to store the values into that. Okay? Store the value into that. You can use, okay, so use ACC read to get this value and use sprintf to store the accelerometer's values to the string. Okay, so I already give the hint. You need this one. So here, basically for this part. Okay, then you can use OLED toString and display this one on the OLED. That's the sequence. Okay, but I don't want to show the code. Okay, so I will escape the next page. Okay. While you are doing that, you can discuss with me, or next class you discuss with me. But if you haven't done that, I don't want to just provide answer. Okay. So that's for the previous lab. So you see, if you finish all my exercises, you have learned many devices already. You know how to control them, at least 2 by 2. Okay, 2 by 2. Every exercise you have 2 devices. Okay, and this week supposed to focus on the interrupt. Okay, we are looking at the GPIO interrupt. Okay, so we have introduced the cystic interrupt. Now we are talking about GPIO interrupt. So firstly, okay, I think I talked about this before, but I just want to re-emphasize here. So interrupt, okay, is the term, okay, you compare with polling. Okay, so polling is basically the regular routine. Okay, something happens that scheduled already. Okay, just like every day you go to the go for work. Okay, taking bus, those kind of things is a regular routine. Okay, and interrupt is something occurs when there is an interrupt signal. So this one may or may not happen. So it's uncertain event. Okay, so and also if let's say this is an event that if it is happened, you want to handle before all the others. Okay, so it's like more important thing. You want to respond fast. Okay, so if I draw the figure to explain the interrupt, it will be something like this. So you have the main task. So this is your regular routine. For example, everything you need to do in one day. So you have the whole day, then tomorrow you repeat the whole thing, tomorrow, next day you repeat the whole thing, okay? If no one disturbs you, you just keep running this, okay? But if something predefined as interrupt happens, okay? For example, your interrupt happens at this particular moment. What you will do is you will pause your main task and start to run something else. Okay, so your flow will be you go here and then you realize interrupt happens, you go run something else. Okay, you go run something else. And there are also cases when you have multiple interrupts. Okay, when you have more than one issue that you want to treat with higher priority. Okay, so for other 2 more important issues, you also have the priority level. Which one is more important, which one is less important. Okay, and let's say when you are running one of the interrupts, something more important coming. Okay, so what you will do is you will terminate your interrupt, okay, the lower priority interrupt, you go run something most important. After that, you go back to where you're from. Okay, you finish your lower priority interrupt, then you go back to run your regular routine. Okay, so this is a figure indicating how different levels of different priority levels of interrupt work if they happen at the same time. Okay, so this is a classification of your Cortex M3 interrupt. This is your RPC, right? I hope you still. Okay, this is your RPC. So it can be classified as something like internal. Internal, there are some issues that are very important for our processor, or something externally. Okay, that you can define. That you connect one of the devices to your processor and say this one is very important, you should keep monitor this. And inform me immediately if someone is using it. Okay, so that's kind of an external interrupt. So internal interrupt we call system exception. Okay, for example, reset, bus fault, usage fault, or your SysTick. Something internally important than some regular routine. Okay. So external other devices, okay, for example, ENT3, okay, anything you connected to your ENT3, you can make it as an interrupt signal. So I think I showed this. You have seen this in the tutorial, right? Tutorial 3, I think. So basically, NVIC, okay, nested vector interrupt controller. We call it NVIC. This is the manager to control all the interrupts. Okay, it's the manager to handle all the interrupts. Okay, for example, your SysTicks. Okay, for example, your ENT0123, your GPIO interrupts. Okay, you also have others. You can have timer 0 interrupt, timer 1 interrupt, UR interrupt. Okay, many things can be interrupt. Okay, so but this guy is handling all of them. Okay, so I think I have explained this one. So you see, normally, if let's say your light sensor is here and you implement it as a polling mode, like what you have done by my exercise, because you code your light sensor inside your Y1. That is your regular routine. Okay. So whenever there's data, basically you read from here. Here is the channel. You do like this. Okay. The data is sending to the arm in this way. Okay, and it's actually a regular routine. So if you have light sensor, you have some other devices, you wrote the code line by line. So your sequence determines the sequence of the arm to read the device. Okay, let's say this is the first thing in your Y1. So this is the path that your arm will look at in the first place. And then if let's say you have other things, then you have other like bars all the way go here. That's the second thing you check. Okay? But if you say light sensor is very important and I want to be, your processor needs to be informed immediately if something happens on your light sensor. So if that is what you want, you need to basically make this thing as your interrupt source. Which means this guy should send a notification to your NVIC. Okay, because NVIC is the manager handling all the interrupt. Okay, so you will see that there is a signal from your light sensor go all the way here. Can you see that? Goes to your NVIC. Okay, so you have this one go all the way here. Okay, all the way here. Go to your NVIC. So if your processor, if you code in such a way that you say light sensor is very important, so your NVIC will start to monitor this input. Okay? So if light sensor has some condition and he gets informed from here, he will tell your arm immediately, and arm will get the data from here immediately, no matter where your program is. Maybe your program is not reading this, your program is doing something else. But it will pause your regular routine and start to retrieve data from here. Okay? So that's how NVIC works. Okay? And if I draw in a simplified way, your NVIC, here is your GPIO interrupt. Okay? Here is your GPIO interrupt. So you can also have ENT0, ENT1, 2, 3. So these are the pins to give you the input of your interrupt. So basically you can get your own device and connect it to here, and you can make this one as an interrupt. Okay? Means you can respond pretty fast based on this device. You are able to do that. Okay? So now let's say if, so your GPIO interrupt, you have many devices using GPIO interface, right? For example, remember your SW3. SW3, there are two options. You can either use 0.4 or 2.10. You also have your SW4, which is P1.31. Okay? So, they are all GPIO devices. But, if you look at your GPIO interrupt, okay, you see only some pins in port 0 and some pins in port 2 are connected to your interrupt or connected to NVIC. For example, this guy, this pin is actually not going to NVIC. So basically, you are not possible to respond fast based on this button. Okay? So SW4 can never be implemented as an interrupt trigger. Okay? Because in hardware side of view, there's no connection between P1.31 to NVIC. Okay? So that's why in your assignment, you are using SW3 to do like the two press within 1 second. Okay? So, okay, sorry, haven't finished. So, in tutorial, you have seen the question like, engineer want to implement 2 push buttons, and either of these pressed, it will show button pressed. Okay, tutorial 3, last question. Okay, so means you want to implement those 2 buttons as interrupts because you want to print the message fast. Okay, so the way is you want to enable your GPIO interrupt. Okay, but your NVIC, okay, whatever signal coming into here, your GPIO interrupt, from NVIC point of view, it's treated as ENT3 interrupt. Okay, so it's better to see from this figure. Can you see that? You have this one GPIO 0, GPIO 2. As I said, only some pins on port 0 and port 2 can be the interrupt source, right? So you see these two are gathered together by this OR gate. So this one is GPIO interrupt. Okay, all GPIO interrupt. Then here you see it all with your ENT3 interrupt. Then you go into the NVIC. So if NVIC realize something received from here, at the beginning it actually cannot recognize it is ENT3 or GPIO. So for him, everything came from here are all considered as ENT3 interrupt. Okay? Get it? So before your NVIC can start monitoring the input here, you need to enable your ENT3 interrupt. Just similar like your SysTick interrupt. If you don't have that SysTick_config function, you didn't turn on your SysTick interrupt. Here the same. If you don't enable your ENT3, your NVIC will not look at this input at all. Okay? So you need to enable your ENT3. Okay, so that's the explanation here. Sometimes the interrupt from more than one device could be considered as a single interrupt by NVIC. For example, your GPIO interrupt and your ENT3 interrupt. So, and these are the GPIO interrupt registers. Also, this one is mentioned in the tutorial, right? So let's say now I want my, so basically your NVIC, okay, and here is your EINT, let me redraw it. So you have your NVIC, and here you have an interface EINT3, okay, and then as I said, because GPIO also here, right? So basically, this guy has many inputs. Many inputs can trigger this ENT3 interrupt. Okay, so what you have here, let's say you have a push button here. Okay, so basically you want to sense this push button. If someone press a button, you want your NVIC to capture that immediately and inform your arm. Okay, so to do that, you need to do the setting of your NVIC. So yeah, so the first one is to enable EINT3. Okay, and when it enable, you also want something to be set. For example, your NVIC needs to know which is this pin, because you are using this one, right? There are many pins can trigger ENT3. So you want to let your NVIC know, okay, this is the pin that he needs to monitor. Okay, so you need to inform him where is this pin. Okay, so for example, we are talking about SW3. Okay, for example, we are using P0.4. Okay, so basically second is you need to tell your NVIC that it should monitor P0.4. Okay, and you also need to tell him another thing. Okay, you need to tell him, okay, he needs to keep monitor this one, and you also need to tell him like what kind of signal you want him to capture. Okay, what kind of signal NVIC needs to capture. Okay, then you need to analyze your push button. You already know that for your push button, if no one is pressing it, what will you see? You will see a 1, right? Because there is a pull-up circuit. So basically, you will see your SW3 is 1 until someone presses it. You will see a low, and the person will release it, right? I mean, let's say if it's not get held, so basically you will see this kind of signal, the SW3. Okay, originally it's 1 and 1. If someone presses it, you will see this kind of shape. So basically, you want your NVIC to capture this. Okay, you want your NVIC to capture this. Okay, to capture this, it can capture in 2 ways. One is you can either ask him to capture this, the falling edge. Whenever NVIC realizes there's a falling edge, he knows that someone pressed it. Or you can capture the rising edge. Okay? Either of this will do. Okay? Means that there's a press. Okay? So either you can use the falling edge or the rising edge. So which one you prefer, you also need to tell your NVIC. Okay? You also need to tell your NVIC. Let's say you want your NVIC to detect the falling edge. Okay? So basically that's the third thing you tell. So tell your NVIC that it should capture falling edge. So these are the information NVIC needs to know before you actually can use it. Okay? So the sequence might change because you may want to move this one to the very last because you want to set it properly, then you turn it on. So basically this is 1. So here is 1 and 2 and 3. So these 3 things are the settings for your NVIC before you can actually use it. Okay? So that's why in the code, okay, so here is your initialization. Okay, this is the initialization. Okay, you see in the main program, actually right before while 1, because these are settings, okay? Right before while 1, okay, you are basically tell your NVIC that it should monitor P0.4 and it should monitor, okay, in my code I'm using rising edge. Okay, so to inform this, we are using these registers to inform your NVIC. Okay, so there are two registers. They call interrupt enable rising or interrupt enable falling. Okay, so for example, I want to tell this information. I want to tell NVIC, okay, monitor 0.4 and monitor the rising edge. So to tell this information, what you need to do is you need to look at the ENR, because that's the rising register. Okay, look at ENR for basically for port 0, because now you are talking about P0, right? So basically there are multiple INT ENR registers for different port. Not only one of these. Okay, so you look at the port 0's this register, go to bit 4 because you are talking about pin 4. Okay, so you put 1 here. So this is a write. So you write the bit over there. Okay, you write the bit over there is equivalent to tell your NVIC that okay, he should monitor P0.4 looking at rising edge. That's the way you inform your NVIC. Okay? So if you are using falling edge, you need to go to this register. Okay, same way to use it. And then you should enable your ENT3. Okay? So you see these are the 3 things we conclude: first, second, and then third. These are the 3 things we conclude in the previous slides for settings. Okay, 3 steps. And then you are ready to use. Okay, you did the setting. Now NVIC start to monitor this one. NVIC start to monitor this rising edge. Okay? So basically in your code, you don't need to keep monitor your push button. Remember in the first lab we did for the second part, we have a BTN. We declare a BTN1 and let it equal to GPIO read value. Okay, port 0, right shift 4, and with 0x01. Remember? You wrote something in this and you check your BTN1 in the if condition, right? So this is a code written by us. It means we are doing the measurement or the monitoring by ourselves. We are using our regular routine to check the button. But now we don't need to do that anymore because NVIC is now checking that. In our code, we don't need to write this anymore. Okay, some other guy is taking care of it. But once he found out this, how it's going to inform us. We need to know, right? We want to be informed immediately, although we didn't write a code. So the way it will inform is, once you have done this, remember it's in ENT3. So whenever your NVIC detect this, it will jump to the ENT3 handler immediately. This is the way NVIC informs us. So it will terminate, it will pause our main program no matter where you are at this moment, and then let you jump into the ENT3. Okay? So this jump will be very fast. Okay? And then whenever you jump into this, means there is this pattern detected by NVIC. Okay? And then inside the ENT3 handler, the thing you need to do is you need to identify whether this is a signal that you jump into this. Because remember in the previous slides I said there are many things can trigger ENT3. Okay, you may not only have one devices. You may have multiple devices connected here and you set them all as interrupts. Okay? So if you have multiple devices, either of these get triggered, you will jump to the same handler, ENT3 handler. So in the ENT3 handler, basically what you need to do is you need to, okay, this is not enable, this is verify the GPIO interrupt 0.4. You want to know whether P0.4 is the reason that make you jump into this. Okay? So the way to check is you have a if loop here. So, but exactly where did we check? Actually, we are checking the status register. So basically, remember these registers for setting, right? And you have actually another 2 registers allowing you to monitor, or we say read. Okay? So once you have done the setup, okay, NVIC now is monitoring that particular pin and monitoring that pattern, the rising edge pattern, okay? Whenever the pattern is recognized by NVIC, this bit will be set by NVIC immediately. Okay? So this is interrupt status rising. Okay? Since you set the rising, you better check the rising. Okay? You set the rising means your NVIC will focus on rising edge. Okay? Then once it realizes the rising edge, it will put the 1 to this status register to inform you. Okay? So basically you need to read from here inside your handler to verify whether this is the reason that you jump into the ENT3. Okay? So inside this, can you see that you are doing IO0, port 0, INT, okay, interrupt status rising register. You want to check this bit. How to check this bit? So basically the blue thing here is returning you the entire register. Then how to check particular bit? You do right shift 4 so that this bit goes to the bit 0 location. You bitwise and with 1. Okay, similar like your push button detection. Okay, so this entire thing will be 1 if this is the reason to jump into ENT3. Okay, so you can write whatever you want to do for the follow-up action. You can write your follow-up action here. Means, let's say if I if button is pressed, I want to immediately turn on my light. That's it. So you need to write the turn on the light, this action here. Okay, so this is a follow-up action. And after you have done that, you need to clear this location. Because remember, this bit is to inform you that the button is pressed. You don't want something happens like if people press it once, you want something repeatedly happen. Right? Usually you want, if button press once, you do something once. If somebody press one more time, you do that follow-up action one more time. Right? That's usually how people do, right? So here, basically you want to clear your interrupt, you want to clear this location, make it 0, so that next time another press is detected, this one will be set to 1 again. Okay? So the way to clear is you use the INT clear register. Again, IO0, port 0's clear register. Okay? You want to write here 1. Whenever you write here 1, it will clear the state rising and the falling register. Okay? Because there's only one clear register, and basically you want to clear both of these. Okay? So it will automatically clear this and clear this. And then you are ready, your NVIC is ready to detect the second press. Okay? So this is the entire flow to create a GPIO interrupt for SW3. Okay? To summarize, in the main program, you need to enable, okay, so basically this is the second one, this should be the first one. You need to declare SW3 as an interrupt, that particular pin, 0.4, okay? And you also want to inform your NVIC whether you are using falling or rising edge. And then you turn on your ENT3 interface, okay? And then in the handler, you want to identify, okay, or verify the preflow that caused you jump into this, okay? And then you can do the follow-up action, or you can set an indicator. Means, as I mentioned, similar as your SysTick handler. Whatever you write in the handler, you want it to be fast, because you don't want to pause your main program too long. You know, your main program have majority things running over there. Okay, you don't want to pause the other things too long, although they are not very important. Okay, so if let's say your follow-up action is fast, then it's okay, you write everything here. But let's say if your follow-up action is pretty slow, okay, you may not want to write here, you may want to write it inside your main program. So the way to do that is you can set your own indicator here. For example, do action 1 equals to 1. Then when you jump back to your main program, you just, based on that flag, you do your action 1. Okay? And then you need to clear the interrupt status. So the code of this one is already given. Demo GPIO INT. Remember in 1Z4 we have 2 projects. This is the second one. Okay? So this is the one you can run directly and see what will happen. So I have load my program on my board already. So this is a code. Okay, so this is the code. This one, demo GPIO INT. Okay, so if you look at your code, okay, here you have the nodes, play nodes. So these are all for the play song function. Okay, so but here, can you see that you have set? Okay, here I'm using P2.10. Okay, so I'm still using SW3, but I'm using the other option. So P2.10, you are enable the falling edge. Okay, you ask your NVIC to detect the falling edge, and then you enable your ENT3. And then in the main program, can you see that you are not mirroring your SW3 at all? So this one is basically your SW3, right? So here you are not monitoring your SW3. This one is SW4. You are doing something based on SW4. So your SW4 is regular routine. Okay? So you see inside here, you don't sense SW3 by yourself. Okay? So once you write this, NVIC will do that. And whenever SW3 is pressed, you will jump into this ENT3 handler. So in the handler, can you see that you have an if loop to check whether the reason to jump into this is this pin or not. Okay? If it is this one, I print something in the console. Okay? And then I can clear. This is to clear the interrupt flag, basically. Okay? So if ENT3 is triggered by something else, you won't see this message. Okay, so you can imagine what happens. When you start to run, this is your regular routine. You start to run, continuously run. So what you are doing here is, you are sensing SW4, and if SW4 is pressed, you are going to play the song. This is your birthday song. So every time your button is pressed, you will play that entire sentence of birthday song, the first sentence of birthday song. Okay? So this one, maybe it will take, let's say, 2 seconds to do that. Okay? It takes some time to play the entire sentence. So during this 2 seconds, basically if you press your SW4, it doesn't get sensed. Right? Because SW4 is a polling mode. This is the only line you are detecting SW4. Right? So while you are running this, you are not running this, so SW4 is not sensed. So here is SW4 get sensed. Okay? This is the only moment you sense your SW4. Okay? That's why if I press SW4, sorry? Am I losing the connection? Okay, let me rewind it. So that's why what you will see is, you can imagine while my song is playing, if I press my SW4 again during these 2 seconds, nothing will happen. Because SW4 is not get detected. Okay? Only when the song is stopped, only when the song is finished, then you can detect the press. Okay? So you see, while the song is playing, I keep pressing my SW4, no effect. You see, and you just play once. That's due to your first press. Okay? If you press during this moment, nothing will happen until your press is done after the song is finished. Okay, so when the song is finished, you can press again, it will play the song again. Okay, that's for our SW4. So basically, your SW4, you cannot sense it too quickly due to this one. Okay, your SW4 is not very sensitive from a user point of view, right? But you also have a interrupt device implemented. You have SW3, right? So as I say, the interrupt is able to pause your main program, right? So what we will see is, during these 2 seconds, if I press my SW3, because it is an interrupt, you are going to jump into your handler and print this inside your console. Okay? And then after it print, it will continue the main program, means you will hear your song continue from that. Okay? So if you listen carefully, so can you see that? So when the song is playing, I press SW3, one line gets printed out here, and then you quickly go back to your main program, play the song, continue play the song. Okay? So if I keep pressing my SW3, you will hear your song is discrete. Okay? So this proves that your SW3 is an interrupt. Okay, so the code here is given. So open this, run this, and understand this. And then I want you to modify from this. Okay? So I give you a exercise here is, I want you to modify this one. Okay? To print on the console interrupt from SW3 or interrupt from rotary switch. So whatever just now you see the print out is actually from your SW3, right? So now I want you to introduce one more device, which is your rotary switch as interrupt also. Okay, so you have 2 interrupt devices. You need to enable both of them, and in the ENT3 handler, you need to identify which one is the one let you jump into the handler. Okay, and print different message basically. Okay, and then start from here, add the declaration of the rotary switch. Okay, you need to refer to the data, the manual a little bit to figure out the rotary switch. And then use the if-else loop in the handler to determine whether the interrupt is caused by the SW3 or the rotary switch. Okay? And here you can actually just set an indicator. Means, okay, what I mean is here. So let me take an example. So whatever you see is here. Just now the program I run, if SW3 is pressed, is pressed, you are going to jump into this, do this print, right? So what I'm saying here is, basically this is your follow-up action. When button is pressed, what's the next thing you want to do? Right? So this is a follow-up action. Let's say I don't want it to be here. Let's say this one is too slow. I want my handler to do things fast. I want to finish my handler fast. What you could do is, okay, so instead of writing this line here, you can write this line here. So basically here, inside here, you can have a new, okay, so let's say you can have a new variable, let's say int flag, and you set it to 0 at the beginning. So when the button is pressed, you set your flag equals to 1. Okay, this one will be fast. This one will be faster than your print. Okay, so this one will be executed faster than the previous case when print is inside this. Then in your main program, you can print this message based on the flag. If let's say flag equals to 1, you will print this. Okay, and then once you print it, you reset your flag to 0. Okay, this is what I mean. If something you want to write is too slow, you don't want to stay in the handler for too long. What's the disadvantage if you stay in the handler for too long? Let's say if you, just now I have a drawing something like this. So I say, let's say this is your regular routine. Okay, let me draw a shorter one. So let's say this is your regular routine. Okay, and if during this is like your play song. Okay, take 2 seconds. Okay, then in the middle, you sense an interrupt. Okay, then you basically will jump to run. This is basically the sync inside handler. You need to finish this one, then go back to the original place, go, right? So I'm saying is this one shouldn't take too long time. What will happen if this one is too long? You see, if you are here and then you run this one, okay, let's say this one is very short. Okay. So let's say you go out and you did a short moment, you go back to here. Okay? And then you see if you start to play the song and I press my SW3 again. I press my SW3 here. You will go to run the handler again. Right? Short one, go back. Okay? And then I press again, you go, run the short one, go back. Right? This is the case if my handler is short. But if my handler is big, so if this is my regular routine. And then at certain moment here, okay, you trigger your interrupt and your handler is very long. Okay, let's say here, okay, let's say here is take 1 milliseconds, 1 milliseconds, 1 milliseconds. Okay, let's say at 1 second you press this one. So basically when you go back, it will be 1 point, okay, let's say 0.1 seconds. It will be 1.1 seconds you come back, right? And from 1.1 seconds, you can continue, right? So all this like 0.1 seconds, 0.1 seconds. Let's say now at 1 second, I run a very long handler. Let's say this one is 5 seconds. Okay? Can you see the moment you go back is 6 seconds? Which means at, let's say, 4 seconds, I press my button again. I press my SW3 again. It doesn't get detected because you are still inside the handler. You haven't cleared your handler yet. This is a moment you clear. Only right before you jump back, you clear your handler. So now, if I press my SW3 again, it doesn't get detected. Okay? So, this is the reason, okay, sometimes you want your handler to be short so that your detection of interrupt is very fast. Okay? And it should be like this, like you don't want to terminate or like pause your main program too much. Right? That like you are using your computer and suddenly there's a reset button pressed. You want it to be reboot quickly and then you can start your work, right? You don't want you reboot, it take 1 day. You never get back, right? So it will influence the main thing, the main functionality of your board. Okay? So this is how if the thing you want to follow up is too long. Okay? So you can do something like this. So that's my exercise. Can you try this one?